Hello everyone, this is the challenge question walkthrough for Edexcel's Applied Year 2 textbook, and this is the last part for statistics on review exercise 1. And actually these two questions are very similar to previous questions from this book. So I'll be going through them a little bit quicker, and if you want more detailed explanations then you can look back on the challenge questions for chapter 2 and chapter 3, where I'll give you a more in-depth explanation. Okay, let's get started. So our first question then, we've got the probability of A being equal to 0.7 and the probability of B occurring being 0.3. And we're told, given that the probability of A intersection not B is equal to P, find the range of possible values of P. So it's basically the exact same question as before, but with slightly different numbers. So we can have, again, the Venn diagram here. Let's call this one A, this one B. The sum of X and Y in this A circle is going to be 0.7. And the sum of y and z in this B circle is 0.3. So we've got x plus y being equal to 0.7 and y plus z being equal to 0.3. Now we want to find the probability of A intersection not B. So A is everything that's in this circle here, so x and y, and not B is everything outside of B. So it's going to be this x here and also the outside section. So what's in both of them, the intersection is just the x then. So x is actually equal to p. So if I replace this x here with p, there we go. We're trying to find the range of possible values of p, and we can do that by rearranging for p here to give us 0.7 minus y. So p must be less than or equal to 0.7 because y is greater than or equal to 0. Then if we rearrange this second one here to get y equals 0.3 minus 7, we can then plug that into the first equation as well. So p plus 0.3 take away 7 is equal to 0.7. And then rearranging for p once again, we've got p is equal to 0.4 plus z. So p must be greater than or equal to 0.4 because z is greater than or equal to 0. So we've got 0.4 is greater than or equal to p is greater than or equal to 0.7. That's our lower bound and upper bound, and we could check if we wanted to that these values work, and they do. So that is our definite range of possible values of p. And that's for part A. Doing a similar job for part B. We just need to have three circles in our Venn diagram now. So A, B, and C. We're told that the intersection of all three is 0.05, and the probability of C now is 0.5. The probability of B and A are still 0.3 and 0.7. And this time we're trying to find the probability of not A intersection B intersection C. So that's everywhere where B and C intersect. So in this portion of the Venn diagram here, and also where not A is. So everything outside of A, so everything here, including the outside section. So where they both intersect then is just this part here, which is where Q is. Okay, and then we can form some equations. So if we call these parts of the Venn diagram x and y, then we can form an equation for the probability of B. We know that's equal to 0.3. We also know it's equal to x plus y plus 0.05 plus q. So we then have that if we rearrange for q, q is equal to 0.25, take away x, take away y. So q must be less than or equal to 0.25. Okay, and it actually turns out in this case that the lower bound of q is actually just 0. And we can just draw a quick diagram, a quick example to show that this is actually possible. So A, B, and C. We've got 0.05 in the middle, and then we're saying Q can be equal to 0. We can just start filling out these probabilities. Let's say that this one up here is 0.15, which means this probability here must be 0.1, so the probability of B sums to 0.3. Then we also know that the probability of C happening is 0.5. So let's say this one here is 0.5, 1, and then this one here is 0.35. So if the probabilities in A are to sum to 0.7, that means we need this probability here to be 0.15. And then the probability overall has to be 1. So if we sum up all the probabilities inside the Venn diagram, we've got 0.3, 0.35, 0.7, 0.8, 0.9. So 0.1 needs to go in the outside, and that is possible. So the lower bound is actually just 0, and the possible values of Q then are 0 is less than or equal to Q is less than or equal to 0.25. And then the final statistics challenge question, question 2. A politician claims to have the support of 53% of constituents. A random sample of 300 constituents was taken and is used to test the politician's claim at the 10% significance level. And part A asks us to use a suitable approximation to find the critical regions for the test. Round your answers to 2 decimal places. Okay, so this is very similar to the one of the questions from chapter 3. So again, I'll go through quite quickly here. So we can model this with a binomial distribution with 300 trials for the constituents, and then the probability of success is 0.53. As n is large and p is close to 0.5, we can approximate this with a normal distribution. So the mean is 300 times 0.53, which is 159. And the variance is np 1 minus p. So it's going to be 159 times 0.47, which gives us 74.73 as the variance. Then, because we're just testing if the politician's claim is correct or not, it's going to be a two-tailed test. So two-tailed test at a 10% significance level means we have 0.05 in each tail. So our critical values C1 and C2 are given by the probability of y being less than C1 is 0.05, and the probability of y being greater than C2 is 0.05 also. Okay, so this is going to be our lower critical value, and we can find that using the inverse normal function again on your calculator. So inverse normal, the area is 0.05 to the left. That will look something like this on the bell curve. So here is the mean, which is 159. The value we're looking for is this value here and this value here. So that's C1 and that's C2. This probability, this area here, is going to be the 0.05, and this area here also. Okay, so we're trying to find the values C1 and C2. Using the inverse normal, that takes the area to the left of the value. So the area of 0.05 is going to give C1. We need the variance to be, the standard. We need the standard deviation to be the square root of 74.73, and then we need the mean to be 159, and that gives C1 as 144.7808, or 144.78 to 2 decimal places. And then C2, if we plug in the area of 0.95, because that's the area to the left of C2, it's going to be 1 minus 0.05. So C2 then is equal to 173.2191868. And to 2 decimal places, that is 173.22. So then our critical region is going to be y is less than 144.78, or y is greater than 173.22 to 2 decimal places. Okay, for part B, we need to comment on the politician's claim, given that 173 constituents said they supported the politician. Now here, although it looks like it's not in the critical region, because 173 constituents is actually less than 173.22, we need to apply a continuity correction, because these are the values of the normal distribution, and 173 is discrete. It's an actual number of people, so we're going to need to compare that with what would be the binomial distribution. So if we draw a quick sketch once again, okay, we're interested in this bit here, this bar where we have 173 for the binomial distribution. If we superimpose that onto the normal distribution, then the continuity correction we need to add is that 173 on the binomial distribution corresponds to anywhere from 172.5 to 173.5 on the normal distribution. So the critical value in terms of x, the binomial variable, is actually x is greater than or equal to 173, because 173.22 is within the range of 173 when we apply the continuity correction. So 173 is in the critical region, so we can reject the politician's claim. So at the 10% significance level then, there is actually enough evidence to suggest that the politician actually has the support of more constituents than they claim, which is probably quite rare in reality. But there we go. And that is the end of this challenge question walkthrough for review exercise 1 for statistics year 2. I hope you enjoyed this video, and I'll see you again soon, hopefully.